This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hello, this is Sriram Panyam from Software Engineering Radio. Today with me I have Amey Desai, CTO of Nexla, and we'll be talking about the Model Context Protocol, or MCP. Welcome to the show, Amey.
Hey, Sriram. Glad to be here.
Before we dive in, you want to tell us about yourself and Nexla?
So I am Amey. I am CTO of Nexla, and Nexla is a data integration platform that allows anyone to move, connect, transform data using no-code as well as low-code processing. Over the last 18 months, we have also built Agentic AI systems using MCP as well as not MCP to help people with the data problem and specifically the data engineering problem. And before Nexla, I've worked at both kind of small and big companies, but I've largely been with, let's say, data systems as a problem for the last part of a good decade. Did machine learning before it became deep learning, and now before it became kind of, let's say, LLMs.
Thank you, Amey. Exciting. I'm glad you mentioned MCP because that's what we're talking about today. Let's dive in. In the last 18 months, 2 years, LLMs have taken over and MCP is the latest thing. What actually resulted in today's world with MCP? As in, why MCP? What is MCP?
Good question to start off. I think what happened is post ChatGPT having its aha moment, everybody wanted to use it for pretty much everything. And that was the promise of the ChatGPT, because you could have a simple UI where you could ask it questions and it would do impressive things, whether they were right or wrong. And one of the key things then people, as they started incorporating large language models into software, just building software, there was a lot of scaffolding, I would say spaghetti code that started getting written when integrating to a variety of different data systems, tools, APIs, call it me. And Anthropic came out with Model Context Protocol being the key word for how LLMs should connect to external data sources and tools. So it's a standardization that I think MCP brought to the table. And that helps a lot in, I would say, software engineering and agentic system today. And that's not just relevant to MCP, but a few other protocols that have come out. But MCP, I would say, is the cleanest protocol and the simplest protocol that we have today.
So before MCP, how were these integrations happening? I believe there were tools. What was the state of the world there?
I think what was happening before was people were using a variety of open source packages as well as REST APIs, and quite a few, LangChain, Haystack, Llama Index, whatnot, and using those packages to writing the LLM part of the code, which was I would say, the sexy part. And then there was, I would say, the harder part, which is how do I communicate to a variety of different data systems? So you would go and explicitly write code for talking to APIs, managing credentials, and all of those details. And how do you want to also embed those APIs with the LLM calls that the frameworks would allow? This was making the problems, I would say, that people are trying to solve with LLMs a little bit more hard, as now you are spending a lot more effort on just the integration part, rather than the actual solving part of business logic. This ended up creating a lot of, I would say, bad code, hard to test, hard to maintain, and hard to reason through things, which is where I think MCP at least allowed you a structure for how to do it. And I think that's the difference right now between MCP versus what was there before MCP, is that somebody can follow a structure to solve the same problem. It still has its own pitfalls, but at least you start from a much better setting rather than a clean slate of, hey, I have to just write code.
So getting a bit more of a visual framing of this. Before MCP, developers would write code, let's say, for example, access their own internal things, tools, and so on.
Right. Everyone was writing, you'd say, custom connectors or custom glue logic, by and large.
Can you give an example of one of these things, like in a real setting? We've all seen the get weather example on OpenAI's page.
Right. No, I think get weather is tool calling at its...
It's too simple. So what's a real world messy example?
So I think a messy example, largely I would say as an engineer, would be GitHub API. You have the GitHub API, which you can do, let's just simple analytics around how well your engineering team is performing, whether that's in terms of number of contributions, whether that's in terms of number of PRs that they have pushed out, how many PRs got reverted, how many was the number of lines of code that you would write. These are 5, 6, 7 different API calls for just one particular system. And you need to write a lot of scaffolding, custom code for how to make somebody like LangChain understand this. With MCP, it's more organized and as a construct available where you define it as a tool call and then can have the rest of the information relevant to the problem statement rather than integrating with pretty much everything under the sun that the GitHub API might need. So that I think was a step change in terms of what developers are doing today. I think the other thing that is now getting to the forefront is using a lot of this framework. You yourself needed to write an orchestrator or how should those calls be called in either a chain or a sequence or in a conditional manner. That only when kind of A finishes, or other, let's say not A, but get all the engineer's information, which is list users as an API call. Then for each user, make an API call to get their contributions. For each same user, make another API call to say how many PRs they reverted. Let's just stick with those three as an examples, right? I have now created a workflow for which I have written very custom code for the use case or the problem statement that I had, which is I want to find out how my engineering team is doing, just at GitHub as analytics. Now with MCP, I can list down those three APIs as simple tool calls and then let MCP take over how to do the sequencing of those operations, which is, I think, what the step changes, the biggest step changes towards now.
Is the sequencing being done by MCP or by the large language model that's optimized for MCP?
It's the large language model doing it, but MCP is enabling that to be done in a coherent, structured manner, and you can reason through those things. When I say reason through those things, I don't mean LLM reasoning, but as a software engineer, you can reason through which call happened where, whether there was access or not, and whenever that call happened, what was kind of the response for it and the accuracy around it. The alternative is you as an engineer is pretty much writing for every single API call, scaffolding code around what was the response that came in? How do I parse that response? What happened when that response errored out? If you think about, like, maybe if you're familiar with Python, you have to write try catch exception blocks for each of these API calls. With MCP, you're relying on LLM to do that for you, which is a much easier way to build systems very, very quickly. So maybe if I can give an analogy, people previously were writing scripts to do this, but with MCP, you can think of your problem solving more as a composition way of doing it. And each MCP, you can think of it as a microservice or a AI.
Or an API, an endpoint.
Correct. Which is much easier to scale purely from a latency and software engineering standpoint too.
So just to summarize and get a better visual picture of it, before MCP, your example of knowing which of your developers are, what the stats are, you write three tools, one for getting the developers, getting their PR counts, and then a third tool for summarizing it. But then you will also write scaffolding to kind of target, let's say, OpenAI to parse out that tool call information in one way, Gemini in a different way, Claude in a different way. But now with MCP, you're saying that, look, all I have to do is provide my three different tools. And by the virtue of all of them supporting MCP, you're kind of solving the multiplexing problem.
Correct. That's a good way to put it. One other example, if I could give Sriram, is, and this might make it a little bit easier, is let's say you just want to create a Python script that convert JSON files on your file system to CSV, and then you want to commit it automatically to a GitHub repository. You can clearly use a framework to do this with LLM calls and prompts to do the like JSON to CSV conversion part. What you'll end up realizing is the prompt to do this is very small. I just want to read whatever is there as a JSON data and convert it to CSV. So if you, let's say, only have a JSON file with 5 keys and you want to convert that to a CSV with 5 columns, the prompt for that is barely 4 or 5 lines of code. Okay, but then you're writing a lot of code to read JSON files, ensure that the JSON files are read correctly, do globbing, ensuring that if it is nested structure that you can get through, do iteration on it, do the same thing for generating new CSV files and writing them out correctly, maybe in a directory structure similar to what you had with JSON files. And then you're now writing code to also do committing it to the GitHub repository, where now you need to handle OAuth and a lot of other things around GitHub, as well as the file system piece. You can register all of these as tools with MCP and then let the LLM take over. And with the LLM's intelligence, a lot of that, call it scaffolding code, call it spaghetti code, but just the integration code is inherently being handled by LLM, which makes the amount of work you're doing much less, which makes the amount of work you have to reason through, just because now you're looking at a lot less lines of code, much easier to manage. And there is an assumption here. The assumption is that the LLM is strong enough to do all of this. If the LLM is not strong, you pretty much are like, we're going to fail. And MCP showed with better models, this is a phase where we are getting closer and closer to.
That's a really good point, right? About LLMs having the capability to orchestrate MCP, right? Taking a low weight model, may not be as effective in this, right? So how did the LLMs themselves have to evolve to actually be more aligned with MCP?
I think one of the key unlocks that happened for MCP to get where it is the reasoning capabilities of LLMs, and LLMs themselves having at least baseline reasoning capabilities today. If MCP would have come out when ChatGPT 3.5 came in like late 2022, it wouldn't have succeeded. The framework itself wouldn't have led to good outcomes. So the fundamental thing that I think changed is that models have gotten better, and what we have realized over a good amount of 2024 and 2025 is models are going to continuously get better. There is this whole construct of we have trained on all the data of the world, and synthetic data is being used now to make models better. The contrarian argument to that is DeepSeek, which came up with a new architecture for thinking with GRPO that allowed that model itself to get better. So the language model as the orchestrator improvement has enabled MCP to get where it is. The other part that I think MCP did is a lot of very good software engineering work in terms of the protocol that is established, which is JSON RPC 2.0, that allows it to have very strong interoperability across vendors, agents, runtimes, file systems, and all of those things. So that is the collection of, I would say, as a system architecture that what Model Context Protocol laid out that has made it go ahead. And I think this might be a hot take, but I think of hallucination as a feature, not a bug. And I think that has started manifesting more and more in the last 12 months, where people don't treat hallucination as a bug completely.
Interesting. How would one go about, this is off topic, but how would one go about treating or exploiting its nature as a feature?
I think creatively, if you wanted to give you kind of more ideas and make problem solving with, I don't want to say infinite space, but a bounded space beyond 3 or 4 actions, it's the capability of an LLM to hallucinate allows it to kind of explore that search space much better. An LLM hallucinates because it is trying to solve problems with whatever information it has. It is exploring search space to get to a particular resolution. If you restrict that search space completely with, let's say, temperature equal to 0, in which case also it does end up hallucinating and reasoning, sometimes poorly still, you're not going to be able to do the language model as an orchestrator at all. You can only then do that for a few set of tools or a few set of functions, which is exactly what OpenAI did with function calling. You had your get weather API or get real the right time or add to numbers kind of thing, right? And you would need to set temperature to almost, I would say, to 0 to get those tools to work correctly. Even if you set it up to a little bit higher, it would kind of fail. With LLMs getting better, that problem to a degree got solved. And now allowing hallucination, if you treat it as a feature, you can start getting into the orchestrator part, because now it can start to think and reason, okay, here are some 7-8 tools that this engineer has put out for me, or this engineered system has put out for me. How do I go about trying out different combinations for them? And if some combinations do end up getting wrong, that's okay. This is going to be an acceptable path of being wrong, and we'll be able to move on past that. Certain domains won't accept this, which I think is fine. And I think people are now clearly realizing that if you're trying to do LLM stuff, let's say with rocket science, where NASA or SpaceX is trying to send rockets up into the sky with the humans' lives at risk, that's probably not a good idea, no matter how good an LLM gets. But if you're trying to do just simplification of your workflows in your day-to-day operations or in the day-to-day businesses where you don't have this much criticality involved, hallucinating is kind of okay. It's not the end of the world if 90% or 95% of my job is happening without me even needing to do it.
That's an interesting take, because humans also hallucinate, right?
Correct.
And it's a big part of how you solve problems, right? In your own dev engineering flow, you're not just going down a single path that you know the exact answer for, the depth first way. And you aren't exactly trying at every combination at every level, the breadth first way. You're kind of doing a A-star approach, trying a few things here, coming back, try something else, learn from it, and so on. And that's kind of what's happening here too, it sounds like.
And I think, at least this is my take, I think hallucination is hyped up for like the dumbest examples that an LLM fails at. It can't count how many R's are there in a strawberry, or I think, is 9.1 greater than 9.9 that Anjay Karpati recently showed. I think I want to say, if you focus on the more impressive things it can do, it can solve problems for you rather than the other way around.
I mean, I'd rather the LLM generate a string or character counter program rather than counting the characters themselves.
Mm-hmm.
Right. Thank you. Going back to MCP and the whys. So traditional APIs, we talked about JSON RPC, but today there exists a very rich universe of API specs. There's this JSON RPC, there's gRPC, there's REST and so on, right? So if you look at the spec aspect of MCP, what value is MCP adding over traditional APIs from the specification point of view?
I think the number one thing I feel it has done is it is vendor neutral. And you can say that the REST API is also
using open API specs, they're pretty vendor neutral, right?
Right. That is on the vendor neutral. No, I think before MCP, I don't think LLMs were vendor neutral. So with MCP, it established parity with what everybody else had in the API land, which I think was an important table stake. Whether that was implicit or not happened by a side effect, I would say is orthogonal. But ensuring that ended up getting people consistency, that they can get the same set of responses or same set of reasoning at least. That's number one. The vendor neutral aspect ensures interoperability, which I think for a REST API also does exist, but you do need to write a decent amount of, again, scaffolding code or to work with that. The other part, which I think is different than REST API, and again, I would say this is a side effect, is it is open source. It made people move all of their things also into the open source ecosystem. It is easy to audit in terms of reviewing code and what you're kind of signing up for. So as an engineer, your work now is, what exactly am I going to get from those endpoints? And by only choosing the tools that you want, you understand the explicit capability that is being granted. If you go look at the GitHub API, the REST API, you have hundreds of APIs there that you may or may not care about. But now when I'm trying to build a specific problem, which is I need to convert this file and then just commit it to my GitHub repo, I am understanding very explicitly that the capability granted to me is just that part of the problem statement. While with REST APIs, you can think of them more as another specification for a general purpose problem statement for anybody to solve any problem at hand. While MCP now allows me to pick and choose what I need and do that very, very quickly. That I would say is kind of the difference in my mind, at least, around MCPs and REST APIs as they have existed.
I'm going to drill a bit more into that, right? So there is the aspect of exposing what you need, which MCP requires you to do, right?
Mm-hmm.
That's not a capability not existent with APIs.
It's not. What I was, I think, trying to get at is I can only work on, if I am a company today, I don't need to build an API specification with hundreds of endpoints. I can build an API specification with one single part and with configuration allow different code paths to happen. MCP would allow me to also create my APIs now in a better way, or in a more smaller / concise way, if that gets sense of what I'm trying to go there. So here's maybe a categorical example I can give from our own work today, where we have seen improvements come. We, as a data engineering company, deal with directed acyclic graphs, DAGs, right? It has a source node, it has a sink node, and it has a variety of transformation nodes that are there. Each of these today has an API for our customers itself, where you have the pipeline as an API, you have a source node API, transformation node API, and a sink API.
Are they REST APIs or just general APIs?
No, they're REST APIs. And this is available on our docs.nexla.com.
So these are all resources that you expose as REST APIs.
Correct. But now I am in a place where I can just create one API. Within the configuration of that one API, I can determine how things are going to go, which is just the pipeline API, let's say. And if I say that the list of input to that pipeline API is going to be an array of nodes, where the first and the last node can be kind of source and sinks, and rely on an LLM to understand this basic construct very well, and figure out what needs to happen as an execution item, which is, hey, maybe just give me information about this node, list particular pipeline, or list just information about the sink that is present in my pipeline. Prior to MCP, we as a company built out 5 such APIs with get, push, port as 3 different action verbs that we can do. So an amount of code that we needed to write was like, if you look at the MVC controller pattern and things on that nature, at least controllers as well as views and then the underlying database code for all of such 5 APIs for 3 different verbs. And that is a decent amount of code. It's like easily thousands of lines of code. Now I can do that with one API. And if I make my specification reasonably well structured with 90%, and this is actually happening live right now in our customer base itself, that one API is able to do all the work rather than me needing to do 5 or 6 APIs. And that one API is not calling all the other APIs. That's the distinction I'm trying to make. That one API has the right specification, which we of course needed to rethink now that MCP enabled it. But if somebody wants to just get information, the LLM orchestrator figures out exactly what to call there.
So what is it calling at that point?
Underlying is just calling one function there, which is still get, put, and post. But all of those are just under one function that one object gets retrieved rather than me separating the object out.
Right. And at this point, is this a wrapper then? I mean, almost like an N+1 offering.
It's a N+1 wrapper, which is correct, but with a lot less artifacts for it to manage in terms of a code base if you are looking at it. So the simplification is at the code base level.
So for companies who want to do this, you obviously have invested a lot in building out that service spec and the service implementations with the various verbs and so on. But if you were to start today, what would you do differently?
What would I do differently is I would just have one API call. And within that, rather we have this already now, which is we have one API call. And within that one API call, we have different functions that are going in places to extract or retrieve or make updates for the end user, rather than separating them out as different nodes, just because those are easier for people to reason through. So let me try to think of maybe another example, because I don't think this example is necessarily putting the picture in place. What I think I'm maybe trying to get at is with APIs, you have a very fixed nature and they're very static, the way you define it. With MCP, you get dynamism as a first-class feature right out of the gate. And that makes building software very different than what we were doing before.
Isn't that kind of contradicting our previous thing? Because you get dynamism, but dynamism is meant to mix and match the tools that are already offered today.
That's what people have started with. But what I'm getting at is I think MCP is reinventing how we are going to build software because of this nature.
Right. So back to your example of how would you do differently, what would that one MCP or the one all-in-one MCP API look like or tool look like?
I don't think it's an all-in-one MCP API, but it's kind of more along the lines of instead of me needing hundreds of API endpoints, I probably need somewhere along the lines of 10 to 15.
Public endpoints.
Correct. That's the distinction. And that as a software engineer, and if you're using MCP even to build software systems, makes it, I don't say much easier, but the amount of work you need to do is a lot less, which I think is going to make a step change in terms of just what you can do with the rest of that time that you have now.
Of course. I mean, I think there's no doubt about the huge productivity boost just using Claude Code and Cursor and hooking up with the MCP tools.
Right.
Anybody who's saying otherwise, I'm sure there's a lot of reflection to be had there.
Yeah.
Thank you. Thanks for clarifying where APIs and then where MCP begins. And I think you're right. We are in a very early stage of how to actually build software in this new way.
Mm-hmm.
Now, obviously, MCP is out there. Google came out with their A2A competing standards. What's happening there?
So it was kind of interesting because I think Sundar had tweeted out to MCP or to not MCP, similar to be or to not to be from Shakespearean before I think the 2A kind of came out. So you can think of MCP, for a lack of a better word right now, like as a vertical solution. That I have this kind of specific verticalized problem. I am going to solve this problem using MCP with tools, resources, and prompts. And that exists as a one single LLM call. And you can, of course, combine them, but as one single LLM call. A2A, Google came out with, which is agent to agent, allows different agents, even across different organizations, to interact with each other and solve problems, which is again like a fairly different architecture than what even we were capable of. So you can now look at a company like GitHub, Bitbucket, and GitLab, and you can make all of those talk to each other. The reason why this is kind of interesting, and this is actually interesting for us as an organization, is we do support on-prem deployments, meaning our SaaS stack can be deployed in our customers' clouds itself. And that's not true for us, but a lot of other companies now. It's almost like table stakes today, right? So the same example that I gave you around engineering velocity, etc., that I'm trying to, let's say, compute, I have engineers who are also contributing to our customers' GitLab stuff, to Bitbucket stuff, so that the private install is on sync, etc. So if I want to get a complete picture, I'll also need to be able to do that. With MCP, I need to effectively write 3 MCP servers that can do this today. With agent to agent,
one for each company handling its own kind of internal tooling. Is that right?
Exactly. And there is a multiplicative effect there, right? One for each private install, other dependent on how many they have, one for each private install. Agent to agent kind of solves that piece of the problem. So from vertical, it makes it horizontal.
Okay.
And that's the big distinction that I have with, I'm mentally, as my mental modelist, when thinking about it. It also has a few other interesting properties around agent cards. I think of it more as agent resumes, where maybe you can figure out what is the capability of this agent, whether it can capability in terms of the reasoning capability, as well as how will it stream updates, how it's going to negotiate, all of that machinery. And Google did make a pretty good effort in solving the security problem also, when two agents can talk to each other, if you figure out from the protocol how to set all of those pieces up. The hot take I have is the reliability of agent to agent is much, much less than MCPs. Because it's just standard distributed system probabilistic math. I think a lot of people, when they think about, let's say, the SLA numbers, right, 99.9999 and so on and so forth, if you have one system that gives you 99.999 and you make a distributed system out of it, your SLA number actually goes down just because of like standard probability there with expectation. And if you have this across n things, you can actually go down to a number as 60 and 70%.
Unless you have replication and
all of that, exactly. All of that machinery, right? So agent to agent is literally like, I would say, trying to do that right now. And I think it's a very, very hard thing to get right because of just that reason alone. That how confident can I be that the GitLab agent that somebody else has built is like very, very good if I don't even like get to see what is done there?
You're talking about availability, right? And SLOs from availability perspective. I think before even that, what about correctness? Now that you have different agents performing different things, how can you be sure?
No, that's what I meant from a reliability standpoint. I meant by correctness. That how do I know that that agent to agent thing is actually even going to work correctly? Like I almost have to try, see it run, and it's almost like with MCP I can unit test. With agent to agent, I have to do integration testing.
Right.
And it is just a much harder problem to do.
Mm-hmm. So agent to agent, I mean, you're using A2A to orchestrate across multiple MCP.
We actually are not. We tried it and we were not. The reliability was too weak, so we did not spend too much effort into that.
Right. And what was causing the low reliability? Were there any general patterns or?
Well, there are, I think, two main things. With MCP, it is open source, so it's a little bit easier to reason, while agent to agent is not necessarily completely open source. Like KPMG as an agent or Accenture as an agent, I just don't have access to it. So the only thing I have is whether it works or not. And if it does not work 70% of the times, it's very hard for me to build a software system or business around it. So that's the only data point that we have, that whether it works or does not work.
From an abstraction perspective, I mean, just for laymen like myself, how would A2A differ from yet another agent orchestrating between two agents?
It doesn't, in that sense. There's a lot of machinery there, which is around the agent cards aspect and the structured task objects that A2A has. So Google introduced this notion of kind of agent cards, where effectively you're writing textual description of what a particular agent does. And it relies on you now as whoever is building a particular agent system here to define that agent card in a well-structured manner. And you're trying to write that in a much more generic way, because you don't know what exact problem might be thrown at you, but you know the capabilities roughly of what you have, but you have to be generic. You can't be very, very specialized, because if you end up making it very specialized, then you can't solve the general purpose problems there.
Almost like an MCP or a tool catalog.
Correct. And in that way, it allows you to at least give the impression that if you were to do this agent card, think of it as like you trying to hire someone and you get a resume, you get a sign that whether this person is worth interviewing or not. Right? But whether that person will actually work or not, you kind of need to go through the interview process, hire them and see them work for maybe 3 or 6 months, and then you kind of know. So that's the timeline you're actually looking at for an agent to agent protocol to give you a reasonable answer about whether it is going to work for a business or system or not. And that is very hard. You could have a templated version of agent to agent for very specific problems where it can shine and work very well. But then the flip question is, then why not just use MCP if you're kind of breaking down the horizontal abstraction and making it
Exactly.
a templatized vertical itself? That's where the simplicity of MCP in my mind wins.
Right.
As an engineer building something, it's much easier for me to build it.
I mean, it almost felt like an N+2 at this point.
I would actually say it's, I think, a little bit N plus N. Like, if I could give you maybe an analogy, it's basically how peer-to-peer communication with likes of BitTorrent and Kazaa was in late 90s and early 2000, where I grew up in India, so pirated movies were a big thing. And it was all happening on such platforms. And agent to agent is kind of going in that direction. And whenever in India, at least internet back then was like really poor. So if you downloaded 70% of the movie and your internet crashed, you lost the movie. So the same thing is happening with agent to agent. Like, it works well, but then when it doesn't, you kind of have to just gets completely unrolled.
And also the other interesting thing you mentioned about agent cards and agent resumes. I suppose it's only a matter of time before we start seeing the Sohamperics of agents.
Correct. I think a lot of people have said this, that we'll have managers, like humans as managers of agents in the future, which I do think will happen, maybe not to the level at which everyone's projecting right now. But if I am managing an MCP workflow versus an agent-to-agent workflow, like, I know what one I want to manage today.
Yep. I mean, I'm sure they're going to have various personalities that you have to, train up for.
Right.
In software, there's obviously standard design patterns and architectural patterns. Are you seeing that in the MCP world? Where are we in terms of patterns and what levels of maturity are they in today?
I think the standard, I would say, software pattern, like we went around like the peer-to-peer one, which also kind of exists in MCP world if you want to create, that definitely is there. I think one pattern that we ourselves, I think, got a lot of mileage out of is the auction bidding pattern, which I think is a little bit present in the ads world in terms of Google, where the auction bidding to a level is you have a problem that you want to solve. I'll actually give a specific example. Let's say I have the data labeling problem that we want to do on our data sets or on whatever data that we have right now. Based on the type of data, I may want to use a different kind of labeling agent. If the type of data is an image, I can potentially use the image labeling tool or prompts that I have created. For text, it might be that person. For audio, it might be a different agent. For video, it might be a different agent. And you might have a combination also of that, the composition for it. So you kind of present this as a problem from your orchestrator, which is like the LLM within the MCP world, actually an orchestrator that sits on top of your MCP world, that, hey, here is a problem. Give me the information about how much will it cost you, what would be the latency, and what would be its accuracy.
Could this be another MCP tool?
Correct. Mm-hmm. It's an MCP tool, but with a very specific orchestration. It's objective.
As the only function, yes.
Correct. Right. And then as a tool, I can then start taking a decision. Okay, this is what the task is. This is what I got back. Now I can award the contract to the best specific MCP tool to go and execute on it. And then it will report back me with results. And I can then also take a decision about, is the result meeting the contract that was given? If not, I can also go and ask another tool that was there, hey, can you do it? You were like the second person who bid for it. The first person has kind of failed. This is why they failed. Here is that's why I'm kind of choosing you right now. This actually did help us do two specific problems at work in the last few months. One was kind of the data labeling part, but the other one was building a PDF orchestrator. You probably know that at this point, unstructured data to vector database is like the bread and butter of data engineering for the LLM territory, right? But the problem is, people, when they're working on hundreds of PDFs, I think it's an easier problem. When you suddenly get into enterprises with 100,000 PDF files, if you run all of those 100,000 PDF files through Vision LLMs, or through high expensive LLMs like 4o, etc., your LLM bills are really high. Like you're spending anywhere between 25 to 50K just on processing 10,000 PDF files, give or take 50-ish pages with images, graphs, and text around it. But what you can do now here is you can, for every page, effectively make a decision. Hey, this just looks, it has pure text, and some of the text might be formatted, but open source basic Python library, call it PDF Plumber, or in the Java world, I think there are many such libraries over years right now. I think I'm forgetting the name of it. I can just have that as a tool call. I don't even need to use an LLM to like understand a PDF either at a OCR level or at the vision level. Just like that basic thing works. That also gives me cost efficiency. It is also very latency efficient because I'm literally doing this in process. So this is one pattern that I think, were able to do with MCP really well. And just hopefully gets across that trying to build this as a system would take multiple quarters, or at least when I was at Google, it would take multiple quarters with very well qualified engineers and teams to even get it right. But here now there are like me and another engineer who have just built this out in like matter of weeks, which to us is like the remarkable part. And of course, it's not like that it works all the time really well. But the fact that for me, seeing what I had seen being built versus now what I can build, the time difference is very, very glaring and comes out very obvious.
I want to go back to the orchestration layer you had talked about just a few minutes ago, right? How does the orchestrator evaluate the result from the different agents to know if it should make a different choice, if it's acceptable or not?
It's a controlled problem that you need to do. The controlled nature of that problem is two things. One is prompts, where you need to treat prompts as a specification, as a software. And then you also need to have a policy enforcement layer in addition to your prompts. And that's how this orchestrator works pretty much.
But in your example, what was the metric for measuring that this agent's result was this?
Meaning post-execution or pre-execution, for like the reward assignment, or after the execution is done?
Well, before the execution, right? Like you would get the result from one agent and you need to know how good it is.
It's interesting, right? So that is actually coming directly from the end user itself, because the end user now can make that decision. What do they want to prioritize? What is the trade-off that they want to do? Do they want to see quick results? Do they want to see the best results? Or are they looking for a hybrid, and kind of let us decide for that? And the hybrid is kind of, I would say, the hardest thing to do. We actually don't offer that as an option. We make the user choose. Because a lot of people, when they're trying to experiment, they want fast results. And then when they want to productionize, they want the better results.
But when you're labeling, terabytes, petabytes of data, right?
I think that is a little bit, we at least haven't had terabytes of data. I think a lot of people today in today's world are trying to generate fine-tuned data sets, which largely are around like 100,000 samples. It could still be a terabyte, especially if you have video or audio data, but the number of samples is much less. I think the terabyte number of rows, like billions of rows, was a problem, I think 8-9 years back when people are trying to build these systems. Now that those systems are built, the volume of the labeling actually has been very different.
Interesting. So the user is still involved in kind of providing hints around.
Yeah. This is definitely a human in the loop system. It's not an autonomous system. I don't think MCP or non-MCP, we are at that stage where you can have a very good agentic system that is truly autonomous. You need a human in the loop today. I think you're going to require human in the loop for at least another decade, if not more.
So what was the end-to-end calendar time for one of these steps to kind of happen in that system you described before?
The entire thing that I, let's say, described in terms of choosing execution to happen. For the PDF orchestrator, for example, for 10,000 files, it took about 1.5 days.
Okay. And how many human interventions were in there?
I think for one specific enterprise customer in the asset management space, there were about 4 human interventions for this entire thing.
That's pretty good.
And the 4 human interventions were kind of largely around the orchestrator, and the LLMs itself kind of recognize different kinds of patterns that each file have. They are also learning from some of these patterns of files. And the 4 patterns, they were just too diverse. It's not like for every little diverse pattern, it makes a interaction with the human. But for when it is too diverse, there is this notion of, you can say, confusion matrix, where is this like not something that you can solve by yourself? And that is when you engage the human. The interesting part here is building this orchestrator. So we kind of build this orchestrator on top of MCP and using MCP. You have to use LLMs, you have to use policies, but you also have to build just status quo machine learning models, which are going to help with such decisions.
Yep.
And that, I think, is the culmination of how all of this works well together.
My next question was, how did you come up with the confusion matrix? Because even with 100,000 files, it's a large sample. So were you sampling it?
No, initially we would have a sampled run for sure. Because this is like a folder structure, right? The folder structure has basically 10,000 files. And you immediately get all the file names. So you can very quickly random sample. And actually, this is where LLMs are very impressive. If everybody writes good file names, nobody writes file names as 1.pdf, 2.pdf, especially in enterprises where things are written out well. Using those names itself, a human itself can infer what are potentially the diversity of data that might be there, and so can an LLM. So the random sampling now is actually a much more intelligent random sample. There is this construct in CS which is called as importance sampling. And importance sampling was largely probabilistic based, like when the algorithm was created. What we are saying is, to going forward, importance sampling is where importance is determined by an LLM for a problem where it can do that. And determining the importance of a file or diversity of data can be framed very easily because it's a text problem.
It's funny because typically pre-LLMs, pre-MCP, the engineering instinct was give entities like IDs, like 1.png, as you said, right? 2.png, 3.png, right?
Mm-hmm.
And I think having actual names on the file names is a very important signal that LLMs have learned to exploit pretty effectively.
And I think there is a very good flywheel effect of this. Now, if you're using LLMs to output also such things, we are going to output sensible things.
Yes. It's almost like we're returning to clean naming. I think naming as a hard problem is getting solved right now, right?
Correct.
Moving on, I want to talk about enterprises. I mean, MCP is fantastic. I think that every day you see a lot of new advances coming out from startups and from, agile moves, right? Enterprise. What are the adoption challenges, hurdles? First of all, I'm assuming there are challenges. How are enterprises doing MCP today, and where can they be?
I think enterprises as a whole are struggling to do MCP today. That's number one. Number two, I think the struggle is by and large around the operations around the MCP servers rather than MCP itself. Because the de facto model when MCP came out was, hey, here is a GitHub repository, check out, run it on your local laptop with Claude, Cursor, and whichever kind of MCP host / MCP clients would support. And that's kind of the end result that you get. So it was still kind of very much based on in a local machine setup. Now we have a bunch of the new work that has happened, which has allowed people to do this at the server level, and it has kind of simplified that. But one of the weaknesses of MCP protocol is by and large the security aspect around it. So prompt injection, MCP to some level gets prompt injection on steroids, where now you can do command injections within your MCP to do tool calling in a adversarial manner. So I gave you the example of file system, right? Hey, read this JSON files, convert it to CSV. So now I have opened my file system via MCP to my users. Now somebody can go and do whatever they want. File systems have commands. Most LLMs know how those commands should run. I can just go and do rm minus rf star, and that's it. Now you're completely messed up.
Or build a tool that does that to kind of circumvent a clear RM calling.
Exactly. So I think that is a big issue that people are trying to address, and that is not a AI engineering issue. It's a core, I would say, software engineering issue. So the problem that I think enterprises are thinking about is some of these limitations of AI are also going to be solved by AI, and they try to solve it via AI, and it doesn't work. And what we are trying to kind of get them to, with our experience and address, is some of these problems are actually not for LLMs to solve. They are to be solved by engineering companies and companies like ours and a lot of other companies in the market right now. And us solving them would help you get MCP kind of generate return of investment in a safe, secured, governed manner. I think the adoption is happening. It's the scalability across the organization is what is not happening today because of such concerns. And also, the MCP is still very easy to get started for engineers. It's not very easy to get started for a non-technical person. Imagine a person who's a SDR. If you ask them, hey, why don't you do GitHub for the Salesforce MCP server, and then you can kind of just start talking to it. It takes them, I've seen people succeed at it, but it still takes them a couple of days to know, okay, what is mcp.json? What do I give it there? Where do I put it in Claude? Just kind of solving the software part. So an onboarder of MCP is kind of what is missing for the non-technical audience today. And keeping up, I think there's a little bit of FOMO that if I don't get the latest version, am I missing out on a feature that others have or my other competitors have? And those get harder decisions because if you don't have, it's like you're trying to do software version upgrades, right? And now you're trying to do software version upgrades with like FOMO inbuilt into it, which was never the case before. People were very thoughtful about doing upgrades because they don't want to break what is already working. While right now it's almost the other way around, where you want to get onto the latest because the latest is going to make things better by default, but it is going to also break your stuff. And you don't know how it would break at all to some level as a non-technical person, while an engineer can control that a little bit better.
Well, I mean, talking about security, prompt injection, for example, it's still, yes, it can be a software problem, but it is largely an AI problem. Or rather, it's actually exacerbated by, reliance on prompts.
Correct. But I think prompt injection will be non-AI problem over time, or will get solved with non-AI technology.
How so?
I don't know yet. I don't think anyone has cracked it yet, but trying to solve the prompt injection problem via a variety of techniques that we have done, even actually evaluation for that matter, with a variety of techniques that we have done, like LLM as a judge, they don't solve the problem. I think they give you a perception or an impression of solving the problem. But it is going to require rethinking some of the how we have built some of the system. It's like how homomorphic encryption or some of these other techniques came out for the problems that came in the last 10, 20 years. That's what AI has brought to the table now. And I don't know of any, but I'm pretty sure in academic circles, there are a lot of people working on this to solve it without AI. And I think that's where the unlock is going to come.
Are there any insights that are pointing in this direction, or are they still based on hope?
I think right now there's a little bit of hope more than insights, that at least from my perspective, more other people might have, but I don't know that yet. It's also because we have not been focused on that as a problem statement.
Right now, we are still in the breaking phase. So.
Right.
What about the other traditional security problems like access management, rules, and authentication? Where and why do MCPs lag today, and what can be done?
I think the protocol itself is lacking that information, and there's a lot of work going on right now to add those things to the protocol. There are a couple of proposals that have been put out, like similar to RFC, but nothing yet has manifested. I expect that to happen over the next year or a couple of years, actually. But at least it's going in the right direction that people are thinking about these problems today. But no one has solved it yet. Everyone's in the process of framing the problem very well and then kind of going in. Because just the mention around access control and everything as a generic statement is, I think, fairly obvious that we need to solve it. But what does that even mean in an MCP world, I think is getting figured out as people use MCP more and more.
Are there any open, almost like formal specification of these challenges that
I believe so. I don't know off the top of my head, but I remember it off the top of my head right now. But there are a couple of proposals that I have seen in the community around this.
What do you see would be challenges for authentication on the MCP world that are new compared to?
I think it's going to be more around the friction aspect about it. Like if you introduce some of the solutions that I think people have pushed forward right now, do you sacrifice the adoption curve?
Right.
And that's, I think, the hard part right now, and which is why I think there's a lot of resistance from the AI engineering side that, no, I want people to use my tools,
right?
Even if it comes at a little bit of risk, which is a little bit short-sighted. I think that's where the challenge is largely going to be.
I guess you don't want the AI user running for the TFA, two-factor authentication, every time there's a new completion, right?
Correct. Even if you take an example of like someone like Zoom, right? They just went on the Mac, they sidestepped all of the security issues, so to say, with a Mac app. They were able to get a lot of users, while like Google Hangout, Microsoft Teams have all of this proper authentication built in, but adoption became a thing. Now adoption is a thing for them, but it was not when Zoom kind of just went up. Having said that, I think there are certain problems that I think definitely we need to solve. Maybe let me talk about the specific ones, right? Like one is just like OAuth tokens. Token theft is going to become a thing, especially if you're using MCP servers. Because everything, if you're talking to all you're doing is APIs, either you're exchanging API keys or you're exchanging OAuth tokens. So if you set up the right tool, somebody can potentially abuse that tool to almost make a man in the middle attack to do token theft. And I think there is a work that is being put. The most basic thing here is we should encrypt tokens at rest. We should use short-lived credentials. We should rotate any kinds of tokens regularly and just like isolating servers part. So these are the things that people are just adding to the specification right now, and then everybody will be able to implement it much more easily.
So in other words, catching up to standard security practices.
Correct. That's not so the prompt injection problem is kind of what I was trying to get at.
Right.
I think that I don't know how we'll solve, but definitely there is it's a open greenfield space right now.
Right. I think back in 2008, there's an app for that. Now there's an AI for that.
Right. I hope there is not an AI for prompt injection personally, because SQL injection did not need AI, right, to solve. I mean, it's not completely solved still, but still at least it's better than where it was when it came out.
It needed SQL then.
Right.
In Nexla itself, what are some of the security challenges you're kind of prioritizing and focusing on?
I think outside of the MCP world, one of the key challenges we have run into are two problems. One is around chunk level ACLs, especially in the whole vector databases, RAG, deep research style problems, where how do you have chunk level ACLs, which is pretty much what row level ACLs in SQL databases at chunk level ACLs for the document databases. That's number one. And I think the number two problem is there is the security delegation problem, which is, and here's what I mean by that. People who use Nexla and any APIs and any connectors, any data systems today, they typically have a credential that opens up the pipes to be able to access data. That gives you, in my mind, purely authentication and opens up the pipes. But then there is an authorization layer on top of it, which is I might open the credential to my SharePoint system. But within my SharePoint system, every file has its own access control, whether a user can access it or not. And that is true across Salesforce. For Salesforce objects, it's true across ServiceNow. It's true across every system that you have today, because every system has an access control system under the hood for it. How do you do this correctly is question one. How do you do this efficiently, I would say, is kind of question number two. And these are the two, I would say, maybe non-MCP, but very much relevant on how do you get the right data with the right access to MCP as a problem statement that we are trying to solve.
Right. And how are you doing? Can you share the progress? Can you share?
So we have since had like a access control system, which is similar to Zanzibar, which is something that kind of Google open sourced like a while back, which is used internally within Google also. What we are doing right now, we also treat this as an integration problem. Instead of integrating with the data system, now we to integrate with the authentications and authorization system itself. That's kind of one piece of the puzzle. We need user consistency across the systems, meaning Amey at Nexla.com and Amey at, say, Microsoft.com need to be the same person. So we need to ensure that the same user is available here. So when they sign up, the two-factor auth with the right email addresses and all of that should be done correctly. And then we need to pull in effectively Amey at Microsoft.com and the access control information associated with that as metadata that's going to be associated with whenever they make a data pipeline. And this is where actually I would say has been one of our strengths, where we are not just saying metadata is just the schema or the samples. Data pipelines and data engineering in general has a lot of operational metadata. A lot of people think of it purely in terms of the crons and the schedules of the world, but it's this access control thing. Who has access to what? Till how much time? When does that change? Things around that nature is what we are solving right now. And we have actually already solved it for a bunch of our customers who are using RAG in this manner with us. It's not that we are guaranteeing we'll give you the most accurate answers or the best answers, but what we are saying is we are going to have secured, governed, and answers that only you have access to and not anybody else.
So, as we wrap up, what advice do you have for enterprises?
I think the biggest advice I would have right now is ROI or return of investment, by and large, would come. It's not evident right now, potentially because of the dollar number going up, but it's very much evident in the productivity boost that everybody else has. So being an AI skeptic is like a 2023 problem. You can't be an AI skeptic in 2025, 2026, quite frankly. There might be a bubble burst and all of that, because a lot of people are solving a lot of problem and a lot of money is being thrown at it. But this is effectively what I don't want to say what the internet did, but the analogy here is the actual adoption of internet made physical stores become digital stores. and that caused a difference in how our economy and everything else grew, the same thing is going to happen for SaaS kind of AI taking over. So that I would say is a thing that's going to happen. For a lot of the, don't over-index on the hallucination and prompt injection as a problem. Instead of that, focus on the access control, governance, and security as problems that you need to get in the hands of your users or in the hands of your employees in a safe and secured manner, so that you can still unlock a lot of value for them. That kind of would be 1 and 2. And then maybe last 3 is a sheepish spiel. Try our company out, Nexla. We have solved a bunch of this problem, including orchestration and security and governance for large enterprise customers across hundreds of internal employees for them.
Sounds good. What about our listeners? I mean, obviously our listeners are very excited about learning this. How would you recommend they get started or advance their learnings?
I think if you're an engineer who's not working in AI, think of spending 20% of your effort at least working with AI. And that does not mean using cursor, but it actually, I would say, trying to solve a problem using AI and see kind of where that would go. Here is a maybe a prescriptive example, right? Everybody wants in software has to do releases. The fundamental thing there is push code to GitHub, start a build job, run integration test, maybe deploy it to a canary or staging pipeline, see it work well, and then deploy it to production. There are about 6-7 steps here. You can build an MCP tool for this in probably a few days to maybe a week if you have all the access tokens, etc., and all of that. Build this out and see how productivity shift it makes for you, where instead of thinking about these 8 things now, you just give a command and then you come back and it is done. These are the places where you want to use AI to simplify your life as an engineer. As a non-engineer, I think a lot of people can probably use AI in their day-to-day things around meeting summary and meeting transcripts and a lot of things around that. But one thing that I would maybe kind of recommend, think through is how can you, like, let's say you have your manager, you have your CEOs, make your MCP tool or your ChatGPT or Claude, give them the representation of what that manager or the vision of that person is, and see how you can help them manifest that vision. And that can make a huge difference in how you work on a day-to-day basis operationally yourself for getting your work done.
Thank you. So it sounds like just embracing it, experimenting with, like, scratching your own itch are key parts of it.
Yeah, pretty much. That was a great summarization.
No. You do all the hard work. So before we close, any other advice?
One last advice would be things that look simple with AI, give them a shot much more than things that are maybe not that simple and will take you a lot of effort to get started. Simple things solve simple problems much easily, and that gets gratification instantly.
Thank you. Amey, it's been very, very, very insightful, engaging, and fun. Thank you for being on the show.
Yeah, thank you.
And to our listeners, this is Sriram Panyam from Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.